Okay, Chapter 2. Um, Chapter 2 starts with simplifying expressions and then moves into solving linear equations. 2.2 and 2.3 talk about the addition property of equality and the multiplication property of equality. I'm going to combine 2.1 through 2.4. So most of the things in 2.1 and 2.2, I guess, and 2.3 kind of run together, and they're things that you all should already know, no big deal. So I'll hit those very quickly, and then we'll get into solving some equations, and that'll be it for this video. So the combining like terms, the simplifying of expressions, basically, that is actually going to go back to your rules of exponents. So let's move this page for just a second. So when we have exponents, and for this, in this instance, in these cases right now, it's going to be an exponent of 1. Okay, so 3x plus 5x, for example. That's an example of an expression because it doesn't have an equal sign. All right, if it has an equal sign, then it becomes an equation. If it's just this right here, it's an expression. So if I want to simplify this, I can only combine like terms. And the way that we define like terms in chapter 2 is different than the way that we define them in chapter, whatever 8 or whatever exponents is. So we need to think about it as a little bit more mature mathematics students and realize that a like term really means that it has the same base, meaning x, and it has the same exponent. Okay, in this case, the exponent for both of them is 1. So it has the same base and the same exponent, which is why we're able to add and subtract or combine these terms. Okay, that's what makes them like. So if we have, 3x and 2y, I can't combine those. I cannot add those together because I don't have the same base. If I had 3x plus 5x squared, I could not combine those because I have different exponents. So knowing that, it should make your understanding a little more clear of what a like term really is, and that'll make things easier when we get down the road and start talking about exponents. So it has the same base, it has the same exponent, so we can add them together. So this is just going to be 8x. Okay, so we add the coefficients, we keep the base the same, we keep the exponent the same. That's also important to remember. When you're combining like terms, you're simplifying expressions, you keep the base, you keep the exponent, and you add or subtract the coefficients. Okay, so that's 2.1 in a nutshell. Now let's talk about 2.2 and 2.3 talk about addition and multiplication properties of equality. And this is where we're going to start talking about solving equations and why we're able to solve equations and why, how this sort of works. So when you very first learned about solving equations, I'm assuming there was some talk of, maybe a scale. You have to keep the scale balanced, or I think Miss Bryson teaches you to draw a line down the middle, and whatever you do to this side, you got to do to this side. Well, the reason for that is because of the addition and multiplication properties of equality. So basically what that says is if I have this equation right here, I can manipulate that equation to do different things, to look different ways without changing the value of the equation or changing the value of the variables involved. So it's just like when we were dealing with fractions in the last video. When I multiply by x over x, I'm not changing the value of that problem, of that fraction. I'm just changing it so that it's easier for me to work with. So if I want to solve this, I want to know what x is. I can move this around so that it makes it a little easier for me to understand. So what I want to do is I want to subtract 3 from this side because I want to have x by itself. I want to isolate that variable on one side. So if I subtract 3 from that side, now suddenly my scale is tipped in this direction, right? So I'm subtracting 3 over here, but I haven't changed this side at all. So it's no longer equal to 0 because I've taken 3 away from this side. So to keep it equal, I have to also take 3 away from this side. Okay, and so then that's when I guess you get your line, you do all this. We don't have to do all that, obviously. So now I just have x equals -3. So that's what you're doing when you're solving those simple equations, but that's why we can do it. Let's see. And basically, let me show you this real quick, because this is kind of the... So the book definition of the addition property of equalities: for any three algebraic expressions a, b, and c, if a equals b, then a plus c equals b plus c. So as long as I add the same amount to both sides, I'm not changing the value of these. I'm not changing this equality. It's still equal, even though I'm adding something, because I'm adding it to both sides. All right, so now let's talk about the multiplication property of equality, which, as you can imagine, is the same thing but with multiplication. So that says in expressions, if a equals b, then ac equals, bc, as long as c, is the same number. So when we look at 3x equals 1, and I want to solve this equation, I know that I need to isolate this x, so I need to get rid of that 3. So the opposite of multiplication, or to undo that multiplication, I have to divide, right? Which really, as we talked about in one of the first videos, is multiplying by the reciprocal. So there is no division property of equality. It's because really multiplication and division are the same thing. So I multiply by 1/3, but if I do it to that side, I have to do it to this side as well. So if we were to line these up to try to show what is what, this would have been our A, this would have been our B, and then the 1/3 is the C. So since I'm multiplying the same thing to both sides, the equality stays equal. So now this becomes x, this becomes 1/3, and so now I've solved it. I've isolated the x on one side, and that x equals 1/3. Life is good. Okay, now the only hitch that they throw in, it's sort of to combine everything together, is now on this one I have to combine like terms. I can, because I have the same base and I have the same exponent. So this becomes 5x equals 5. And now I'm going to use the multiplication property of equality to multiply both sides by 1/5. Okay, so this becomes x, this becomes 1, so x equals 1. Okay, and on this side we're actually adding in the distributive property, so 2 times 3 is 6, 2 times 5x is 10x, equals 12. So on this one I have to use both the addition and multiplication property of equality. So the first thing I want to do is subtract 6 from both sides, so I have 10x equals 6, and now to isolate that x, I'm using the multiplication property of equality. I'm multiplying by 1/10, or dividing by 10, however you want to think of it. So this becomes x equals, now I have 6 over 10, which I can simplify to 3 over 5. Okay, so basically the moral of 2.1 to 2.4 is going to be, make sure that whatever you do to one side, you do to the other side. And to make sure that when you are combining like terms, to truly have a like term, you've got to have the same base and the same exponent, and then you just add or subtract the coefficients. I'm going to take a quick look through 2.4 and make sure there's nothing else kind of tricky in there. And nope, it's all pretty straightforward, just solving simple equations, so we should be good with that.